session today, and this class is basically a demo class wherein we'll come to know about MongoDB, why it is to be used, what is so special about MongoDB, why it is so hot, and all those things. Today's session would not be focusing on any of the technical aspects. It would be basically giving an idea of what MongoDB is and how it is different from whatever is available in the market. So to start with, I'll like to set a few things. If you have any of the questions, then you can unmute yourself and you can ask straight away. And if there is a point that you are not understanding, it would be like good if you can just stop me there and then we can clarify. And what else? Okay, so let's start with MongoDB. So it is like about me, what I do. I have around 5 years of experience in the software industry, and I am basically a Java guy, and I've worked with SQL and NoSQL DBs, and one of them would be like MongoDB. And recently, I have developed quite a bit on MongoDB, and I've designed allocation engine, which is related to sales order fulfillment for Inspire Commerce, that is based out of North Carolina. And right now I'm working with Cisco San Jose, and it is for the X1 syndication project. And here we are using microservices in MongoDB. So we'll also talk about how MongoDB gels with different kinds of products that are available in the market, like Java and Springs and all. So apart from that, hobbies would be to dive into latest of the technologies. And what I would help you with is, apart from the technical stuff, I would share project experiences and business cases as well. So the agenda for today would be like what you know about SQL versus NoSQL DB, what it really is. Then we'll have a bird-eyes view of the structural DB, that is the document-oriented DB, and then we'll come to know about why it is highly valued, then why MongoDB is wildly hot. So there are a few things which you must have heard, or you may have heard before, or you may have just searched the internet and have come across words like agility, flexible, schema. Then we'll have a small example. That would be the blog post example, to just relate to how easy it is to design in MongoDB. Then we'll see some jargons like vertical and horizontal scaling, and then we'll see if what MongoDB says that it is horizontally scalable. So is it possible without MongoDB or not? And then we'll see what are the job trends, and then we can close it up with the course content and walkthrough. So there is a saying, Eric Raymond, one of the guys into the trade, he says that show me your code and conceal your data structures, and I shall continue to be mystified. And he says, if you show me your data structures, I won't usually need your code. It would be obvious. So this thing fairly makes sense, and it makes us available. It lets us know that how important data structures are in today's world. If we talk about 1980s, when development used to be there, then we create everything in objects and model everything in classes and objects. So the problem that we were facing with relational database was that whatever the classes are, we are not able to match it directly to the relational database. We have to go we have to analyze, and then we create tables, a lot of joins, then we create keys to share data and all. Okay, so what this thing suggests is, now we are moving in an era where data structures are becoming important. So if you see languages like MongoDB, Spring Boot, and a lot of technologies that are coming up, what they are using, they're they are using a design that is closer to the modeling side. The way we model the data, it is using the same thing, and the languages are evolving. Okay, that is the point. So we'll move to the next slide. Okay, just to give you a brief on what MongoDB is. MongoDB is a NoSQL database, we know, and it is document oriented. We'll come to know what it is about document oriented. And Tengen is one company that came up with the idea of document oriented database. So if you read the slide, it says while you were sleeping, Tengen, the company behind MongoDB document database, changed its name to MongoDB. It raised around to $31 million and became the first $1 billion open source startup. That's right, an open source NoSQL database startup. So this company, as on February 2015, MongoDB is the fourth most important or most valued DB database in the market available today, and you can say it is the only NoSQL DB that is so highly valued right now. We'll come to know about why it is so valued and what it offers that others do not offer. Am I clear? Am I audible clearly, or my voice is breaking? Can I get some feedback so that I can continue ahead? Hello? Can I get some feedback?
Yeah, Darshan here actually. Means are we not going to bit technical about today? Is it only the business perspective or like that?
Yeah. It would not be definite. It would not be that technical. Today we'll just see what things this MongoDB offers, because this is a demo class. We are setting the tone for the days ahead, right? So today would not be totally technical, because for that we'll have to start with the class 1, that is MongoDB 101. We'll have to start with, and then only whatever the jargons are, that would become clear, because the terminology here is not similar to SQL. But yes, definitely I'll give you a feel about how it is. Okay.
Yeah, sure. Thank you.
Okay. So I would just like to say, if you can just give me feedback with time to time, because when there is no sound, then it does not become clear. I mean, whatever I'm saying is making sense or not. Okay. So we'll make it interactive. So we'll start with our agenda now. So let's talk about SQL versus NoSQL. So if any one of you can just let me know what notion you have about this thing, SQL and NoSQL. What do you know about that? Anyone can answer. Actually, I do not know who all are in. Can I see the list now? Yeah.
SQL is a relational database.
Yeah.
And NoSQL is non-structured database.
Non-structured. Okay. What else? What else you can come up with for SQL versus NoSQL? Anyone else would like to give a point on what you have been doing for now? I mean, of late you've been using SQL only. So, what is it that you fear the most in SQL? Anyone? Can we unmute all of them so that I hear, because the sound would not. Yeah, can we unmute all of it? So, does anyone want to answer yes or no? At least give me a no so that I can continue.
SQL are basically relational databases, whereas NoSQL databases are non-relational databases.
Non-relational. Okay, so let me make a point about SQL versus NoSQL. When we talk about SQL databases, this term is like a general term, wherein we take Oracle, MySQL, and what all variants are available. And basically, when we say SQL databases, we talk about relational databases only. But what is relational database? Where we have tables, we come up with a schema diagram, then we divide the entities, we prepare an ER diagram, and then we identify the keys, then the constants, the data types. So a lot of brainstorming goes into designing a relational database. Any which ways, even if we design a NoSQL database, brainstorming is required. But the main point is, NoSQL DBs provides you a way wherein you can start quickly. Why quickly? Because the setup required is not that lengthy. I mean, you need not come up with an ER diagram. You need not set a schema. You need not define anything. And why NoSQL DB like MongoDB is so great? Because the schema that MongoDB follows is the same as that of the class that you have. So I can say that when you are in the design phase, you are deciding on the designing of your classes, then whatever the classes you have, that translates directly into the NoSQL DB. This we'll see in the blog post example. So let's move on and we see a structured DB and document oriented DB, what it is. Okay, so this one is done. And just for a fact, I mean, you can check the internet. As of February 2015, MongoDB is the fourth most popular type of database management system, and it is the most popular for the document stores. If we see the other DB, we can just go through it as well. I mean, in the PPT, we can see that the creator for MongoDB is Tengen, and initially it was known as Humongous, and it is built on C++, which is a very native language, and most of the developments of compiler are done on C++ just because it is very close to the hardware. Now, just going through the definition, I need to cover this PPT, so just going through the documentation, we can know that MongoDB is an open source document oriented database designed with both scalability and developer agility in mind. Okay, so just keep these two terms in mind. We'll focus on these two terms only today. What is scalability and whatever is agility. And instead of storing your data in tables and rows, as you would do, it has a JSON like document.
Hello.
Which yes, please.
Hello.
Hello.
Yeah. Hello. Who's that?
Hello.
Hello.
So it has this dynamic
Hello.
schemas and all. Okay.
No.
What is MongoDB? So the goal is to bridge the gap between the key value stores here. As we know, hash map is one thing where we have key and values. Similarly, everything that we store in a document type or a NoSQL type of DB, it is in key value pairs. Whereas in SQL databases, we were having rows, though each row was having one primary key, and we can say that since we can retrieve using a primary key or what, and it can be termed as key value. But here the key value is not in the sense that we have a primary key and it will fetch the entire row. Here we can have a key and fetch an entire object, though, which you can translate as a row, but the difference is difference is there. Okay, so we'll see that. Okay, so moving ahead, we see that initially whatever the relational databases were, they were not designed to cope up with the scale and agility challenges that face the modern applications, nor were they built to take advantage of the cheap storage and processing power available today. So how many of you have been to data centers? Can I get some feedback? Have you been to any data center? Have you seen some servers or rack? Anyone? Have you seen a server, how it looks like? No feedback. Okay, I'll continue then. Let's understand what agility basically means. The saying is that iteration is the fundamental dynamic. So iteration facilitates the adaptation, and adaptation wins competition. And history is littered with the carcasses of superior contenders that simply didn't adapt as fast as their victorious challenges. So let's understand what agility means when it comes to MongoDB and how MongoDB offers agility. So if you guys have heard about agile methodology of software development, then this agility is a process where we do things in iteration, we do things in sprint, where we have a common goal in mind, but we divide things into chunks, into tasks that we'll do one by one. But with each task, we do sprints and we improve and we reiterate what is to be done, keeping in mind what has been done. So this is kind of iteration. So I'll just give you an example, a real example which you might have faced in your development. When we develop initially, we start with a small picture. Though we know, according to software development requirement phase, once it gets over, so that is considered to be sealed. But in real life, that is never happening. Each day, each passing day, requirements come into you. So when you start, though you start with a holistic view, that view changes at the time you are about to deliver. So each day you are getting change requests, some updations in the requirements or some suggestions, even the UI design changes, and the class model also changes. So just imagine if you are using a SQL database and you have done all the brainstorming that is required to come up with a SQL schema, and you have done all the ER modeling, and then suddenly client says, boss, I do not want so and so class there, I do not want so and so functionality, and then it would not be logical to keep that thing in the model of your SQL, or even in your class diagram. That part should not be there. So now the point comes that when you have to remodel your ER model, and you'll have to just recalculate the dependencies, whatever foreign keys you have placed into that particular table that would not be there, you'll have to come up and design totally everything from scratch. So that is time wastage, and you are not going to deliver quickly. Okay, now when it comes to MongoDB, you will come to know why it is not as why it is easier to work with MongoDB. I'll show you as well. If you do not need anything, you can drop, and it would not pose any issues to the data structure. Okay, what I can do is I can take you to one of my projects, and I can show you a class. I can show you a class. If you see this, it is sales order class, and we have defined a structure here. We have a sales order that derives from the base document. We have IDs, we have header, and header is also one of the objects. Okay, look, these all are fields inside the header. Okay, and we have a list embedded into it. We have list of notifications. So this is composition here, and we have logs in this object. We have some other objects. So this sales order object is a very complicated object where it has around 3, 3, 6, and 8, around 8 embedded objects, and a lot of things going on. So just imagine if you have to relate this thing with a SQL DB, where you would come up with tables. So you'll have a separate table with sales order header. Then you'll have a table for the sales order data. Then each of these would be a key. And since this is a list, since this thing, sales order line is a list, so you have a table for a sales order line. But again, since this is a list, you will not be able to hold all the rows. You will have to come up with a staging table when you are holding the key, just like you do with user and roles. Since the roles can be multiple to a particular user, you have a one-to-many relationship, and you come up with a staging table. So one staging table for this, one staging table for shipment requests, one staging table for notifications. Just imagine how big your structure would be. There would be around 15 to 20 tables that you would have to make up just to cater to this single model. Okay, so this means the space is increasing. The time to query would increase, because to fetch the complete sales order data, you would have to query all these tables. Okay, if you are getting my point, just give me a feedback. Okay, or you can put it in the chat window. Now we can go to MongoDB and see if sales order. I'll let you know what all these tools are. Okay, I'll show you this thing later. But I've made my point here, and we'll move to the next slide for now. I'll show you that thing. So let's understand first the basic things, what documents are, and how it is easy to develop in MongoDB. So MongoDB is a document based, where the size of each document can be max up to 16 MBs. Documents are in JSON format, that is a binary JSON format, you can say, which we'll see in the next slide. And it consists of field and value pairs. Each document is stored in a collection, and collections can have index sets, tables like the tables of relational DBs, and documents do not have uniform structure. Okay, just going through the next this as well. If you see this data model, when we talk about JSON, that is the binary JSON, we can see this thing. This is a JSON. If you guys are familiar with JSON format, please let me know. Okay, so this is the JSON format where we say hello is the key and world is the value. And here we have a JSON, and it says awesome, and some values are there. And these are the binary representation of whatever is mentioned on the left side. It is lightweight and it is efficient to use. Now, before we start totally with the MongoDB, let's be aware of what are the 4 categories of NoSQL databases, and each one is a key value type, each one is NoSQL, but again there are variations into how they use that key value fundamental. So Amazon's Dynamo paper and Voldemort project by LinkedIn, these are totally key value. Okay, then we have something as graph, where we have I suppose that HBase is a Cassandra is column type, and document store we have MongoDB and CouchDB. Google's Bigtable and Cassandra, that is developed by Facebook, these are also available. So there are some categories that are coming up in the NoSQL stage, and the future would be driven by these only, because some of them offer very good transactional capabilities as well. Now let's see how the term mapping is there, so that you get acquainted with the terms. In RDBMS we have tables, but in document DBs we call it collection. So makes sense. Instead of view and rows we have JSON documents. Indexes are there, but the overall implementation and how it is indexed actually, concept wise, it would change. Then instead of joins we have embedding, that is very useful, which we'll see today, and linking. also. So BSON documents provide references. Each of these things will definitely go through in the course content and in the actual technical classes. So in the demo class, I'm not touching these jargons much. In RDBMS, we call it partition, where we divide things into, we divide the tables, we manage the load across the servers. Here we do sharding, and instead of partition key, it is the shard key. So it is just terminology difference. Conceptually, they work the same way, but the implementation would change. So this is something called the this is the RDBMS join, and this is the schema design. Okay, I'll go back to my PPT where I have few things to show. So let's get acquainted with JSON first. So JSON, as we know, is JavaScript object notation, and it is why it is very important and why it has emerged as the de facto way of information interchange. Instead of XML nowadays, most of the technologies they prefer JSON, and the world is moving towards JSON now because a JSON is human readable as well. It is easy for humans to write, whereas XML is like too verbose. For just a simple thing, you will have to write all of the most of the things, and then you define the tags and the descriptor for that, and then you give the schema language for XML only. So it is too much of work. So JSON maps directly to the object-oriented world. It is easier for computers to parse as it is like plain string, and through JavaScript loops and parsers you can directly parse it. So it is like easier to work with. Objects can be nested, and it is based on the concept of key value pairs or name value pairs, as you can say, and it supports other data types as well. BSON, you can say, is an extension of JSON where everything is like binary encoded. It allows for referencing, just like the foreign key. You can reference the other object as well, and it similarly like JSON, it allows embedded structure, and basically this is what makes up for the MongoDB. Okay, now coming to the point why MongoDB is widely hot. Okay, so these are two important points that you would like to understand why MongoDB is there and what is it in the world of IT that is changing, that people are coming with new technologies, and we have whole whole fleet of NoSQL DBs in the market available today, and whereas we were having only a few options in the relational space, and now everybody is fighting over NoSQL space, and now there is so much of competition in the market, and there are various things that people are doing with emergence of the NoSQL. So first of all, I would like to draw your attention towards the linguistic innovation that has happened over the period of 30 to 40 years in the IT industry. If we see that computers initially, talk in terms of binary. So we were having C++ kind of languages, and before that, you can just look at the history. With each passing day, the languages have emerged only, and people are coming up with languages that are very easy to understand to human, so that they can write it efficiently, do different things. There is a concern on security, and a concern on efficiency. Performance is one of the factors that is driving this linguistic innovation. So when things are becoming easier to understand, then with this growing innovation, the relational side was like leaving behind, and it was not able to catch up. So you can say that the theory of adaptation uh, applies here, that relational DBs were never designed to keep this thing in mind, and they fail to adapt as well. Okay, so the new breed that has come up is document oriented DBs, or you can say the NoSQL DBs, where they are using the latest uh, information interchange format. If you see the JavaScript side, few years back, JavaScript was one thing that people understood, that browsers understand JavaScript, and it is used for some UI related play, and most of the code was written in Java. But now, if you see the JavaScript stack, you have the entire mean stack available. That is MongoDB with Express.js and AngularJS, and with Node.js as the server side. So you can do away with totally any of the server side technologies like Java, ASP.NET, or anything like C, C++, and you can come up with a web application. Why MongoDB is so hot? Because it is in line with the latest practices of quick development. Because now the front side, where the front end side, or you can say the server side languages, they've they've come up to a level where in 5 to 10 minutes you can just run your entire web application on server. To just give you a point on this, if you know, if we create a web application in normal core Java using Eclipse, and if we'll have to use Tomcat as the web container to run it, it would at least take us around half an hour to 1 hour to do simple hello world program that would be running on a sublet, simple hello world sublet program that will be running on Tomcat. But if we use Spring Boot, it would hardly take us 5 minutes to come up with a POC on login. Okay, because everything is like through POM and embedded. So these things are providing fast ways of development. So why we have to spend so much time on the relational side? That is why MongoDB is there. You can just translate your objects directly using Spring Data projects and work directly with MongoDB. You need not focus, or you need not define anything on the server side. The object would be persisted as is in the MongoDB. Secondly, there was some object relational impedance mismatch. Okay, that the real world is modeled in classes and objects. The point that I started earlier. This is the point why MongoDB is really hot, because the relational world do not map directly to object and classes. Whereas if you see this, if I'll show you, there is a this is a what I can show in this. If you see this organization, then if you see this, here we have ID, class, company name is there, organization data, domain is there, and ref name is there. And the structure, it has context inside, which are the ref. This is in JSON format, so this is ref to the ID. Then we have context inside, primary context. So if you just see the fields, that it has company name, a data domain field, a ref name, and context inside. And if we just open the organization model, it relates directly to this. It has a company name, it has list of contacts wherein you can put, and there are few other things are as well. So one of the most important feature of having SQL and NoSQL DB is, in SQL the fields and properties would be there even if these are not available in the actual data. But if you see this model here, there is no dropship site name, because this organization does not require that field. So this is what flexibility means. If I need any other property apart from the ones mentioned above, it would be here. So whatever the rows, or you can say whatever the documents are in the collection, they can be different. But the class defines the schema for the MongoDB document. It would not strive away from this. If we see this organization, there are so many fields, but not all the fields are present in the database because right now they are not required. Once they would be required, their value can be saved to their database. So that is the point. Moving on next. Okay, let's do a blog post example. So all of you, I assume that are familiar with the SQL world, and if we see a normal uh, blog post example where we have a blog post that is with the some author has written that blog post. So we have a author ID, that is the foreign key, and it goes to the author, and author has few attributes like name, email. It can have an address, it can have some other information, it can have multiple addresses, it can author can have 10 addresses from it can have office address, home address, temporary address. So we cannot uh, create so many rows or columns in author class. So what we'll do, just to maintain the addresses, we'll have to create the another table of address and just reference using one-to-many relationship here. Then the comments are there. So this is also one-to-many. A single blog post can have many comments, right? So these comments, whatever are there, we are maintaining. So the blog post ID is the staging table here, where we have the blog ID, the tag is there, and the blog post ID is mentioned in the comments. So we reference from this ID to this. So you can imagine just to find, just to populate the entire blog post on the UI, so many joins you'll have to do, where on the UI, if you have to show author information together with blog post content, what all comments are there, and what all tags that blog post has. So to show this much information on UI, you'll have to query around four tables and do a lot of work. But if you see this is my structure. This is my structure for the document that is available in MongoDB. So to show this on the UI, I need not query anything. I can just query the collection in which the block collection in which this document is, and I can everything gets set into the Java object, and then through getters and setter I can do a get author, whereas get author returns the author object, wherein author object contains the name and the email and other information. If author contains multiple addresses, I need not worry. I can just have a address array inside this JSON, just like I have a comments array inside, wherein I can have a address object composed inside the author object, and in the blog object, author object is composed. Then this is the actual post, date, time, location may have a address, latitude, longitude. So what all that object is, if you can consider each key value thing as an object that is embedded. Comments thing as an array, where this is one object, this is second object. Okay, we can have multiple objects and everything is in this array. You can say this is array list of comments embedded inside the blog post object. Then we have the tags. Tags is array list of strings. You can have array list of any of the object. You can have array list of strings where each string is politics, Virginia, or whatever value you want to put. So tags is array list. So if I want to create a model, if I want to understand what is the data structure of this, just by looking at the MongoDB document or by looking at the Java model, I can understand. So how the class would be? The class would be like class blog, and then inside that I would have few things like ID, then I would have author. Author is object, and then I would have a post. It looks like a string, so I would say string post. I would say author, then I would say date. For the location, I can have a coordinates class where I can say coordinates. Then for the rating and comments, I can have a comment class and I can say a comment here, but it would not be a single comment, it would be a list of comment, and I would say comments. And then for the tags, I can have a list of string and I can say tags. So this class looks exactly like the MongoDB model. So this is why we say you show me the data structure and we know what you want to do. So that part is justified here. Now, what MongoDB is good for and where are the few areas where it is still not being used, but I tell you I'm using it one of the things where it is not being used earlier, but I'm using it for that purpose only. And since that thing is not in production, I cannot be really sure on that thing. So MongoDB, as we say, is very good for holding the data as per your model. So where you want, you can use it for account information, user profiles. You can use it for application like where you go and check into a theater or a coffee shop, small application where the data is not that critical. For the web applications, blogging, messaging, system configuration. For logging also, MongoDB is very useful. Where you want to come up with complex graphs, there MongoDB is useful. Location based data, and I tell you, using this geo queries that are available as part of Google's JSON project, MongoDB is the only one that offers very easy way to query geographic data. So that is there. MongoDB has not been used for financial transactions like projects because it doesn't provide transaction management of its own. Each MongoDB statement is atomic in itself, it follows ACID. So whatever query you are doing is like fail safe, and there would not be any bugs or transaction glitches into it. But when it comes to maintaining transaction across collections, or for your understanding, I can use the term tables. So if a transaction is to maintain across tables, updations and deletions are across the tables, then MongoDB has not been used till now. The project I am working on is definitely trying to do that. It is a commerce project where I am working on sales order fulfillment or coming up with a engine that deals with allocation or fulfillment across different inventories. So there, if I show you, I cannot show you right now, but there are inventories across which I have to maintain the um, in sales order. I have to identify quantities there or not. If quantity is available, I have to reserve. If Since it is a multi-threaded environment, if someone reserves it first before I reserve it, I'll have to roll back since the sales order cannot be fulfilled completely. So that project has a lot of transaction requirements, and I'm catering to that using few of the methods provided in MongoDB only. But that thing is in not in production, but that thing is working. We have tested as well. It is still into phases which I cannot talk about right now. But MongoDB is one of the amazing things. Why? Because you can start on MongoDB quickly. It offers few things which no other database is providing in the market, like scalability, flexibility, and other stuffs. So let's see if what first of all what scaling is, and can we do it without MongoDB. So when it comes to scaling, I'll tell you this thing. This is vertical scaling. When you launch an application, your server is this size. If you are using a RDBMS or a relational database management server, your server size would be this size. But if you see your application is gaining attraction and a lot of people are coming towards your application, so you need more data storage capacity. So you have to buy a bigger rack. That means you have to invest some amount to get this bigger rack, bigger space. After 90 days, you see a lot more data is coming. You cannot put two racks of the same size. You have to just increase the capacity and balance the load of data in the CPU cores available in that servers. So the size would increase. Then after 6 months, then you want multiple racks to handle. So this is single server having multiple cores, multiple processor. Here we cannot do that. One server is here, one server is in Chennai, one server in Mumbai, and then data is shared across all that. That is not happening here. It is not partitioning. It is your single application is hosted on a single server. But if you see this, with growth of time, with increasing time, your size and your investment on servers is increasing, and definitely for this big server you have to invest good amount of money. Why MongoDB is good? Because it doesn't scale vertically, it scales horizontally. You have a laptop, you can host data, you can host a MongoDB server there. I'll show you my MongoDB server. This is my MongoDB server that is running, and I'm connecting to this server. Now if I want this, the space available on my laptop is not sufficient, I want applications to have more space, I can put two laptops together and start one instance of this MongoDB on that as well. I would connect through this only. I would not come to know from where data is coming. That would be handled by MongoDB automatically. It would be automatically sharded, data it would be automatically replicated onto slaves and master mode, and nothing you will have to do, just little bit of configuration, and then you can scale. Now if you see the load increasing even higher after 2 months, then you can put 3 laptops, and then you can keep on in scaling it horizontally. You can buy a small rack, even if small rack comes cheaper as compared to a bigger rack. If you don't want to invest in rack, don't invest in rack. You can put tens of hundreds of laptops together and just install MongoDB on that, and then it will run. So that is the beauty. This is what horizontal scaling is. You need not invest on this infrastructure. That is bad. Now, one more downside of using RDBMS databases is when your project starts, you have some database design in mind. But as the complexity increases, your query cost increases, and complexity of query increases, and queries are taking too much of time, then you come to know that you have normalized your data too much. That much is not required. You'll have to denormalize it so that you can ease up on joins, ease up on referencing. You denormalize the data, then again some code changes, because since the database schema is changing, your query would change, then your Java code would change, so many changes. Then after some time you would see that your application is not scaling still. I mean, you are not able to cater to the number of users, number of hits that are coming on your servers. So what you will have to do, you'll have to denormalize it again. You have to identify a way wherein you can, you have to do something or other thing where you can stop using joins. Then still you are not able to scale up to that level. Then you'll identify data that can be cached. So you'll put some caching layer and go and visit your database only when required. Okay, so that part would be there. Then you'll have to do sharding as well, or you can say partitioning. So all these things are nothing but wastage of time, because to do these things you need time, and ultimately each time your Java code is also changing. So application is like undergoing a change every time you are messing up with the database. So this thing decreases developer productivity. So now in today's world, you need to be productive. If we see the job trends in MongoDB, this is data from Indeed, and it is till January 15. The graph is ever increasing, and this was January 15, and I'm sure uh, in April 15 it would be like way high. So each passing day, jobs and requirements on MongoDB are coming up, and if you see this left hand side, it is somewhat around 0.2 percentage of the jobs in the market are in MongoDB. And now you would say zero point 0.2 is like very less, but trust me, Indeed.com, you can search this on internet. Indeed.com pulls up data from more than 150 to 160 job sites across the world, and the the jobs listed on MongoDB ranges from millions to billions. So on that scale, zero point 0.2 is like very high. Now we can go through the course content. Uh, I can go through the